Today we read about importance of Kc or equilibrium constant. Equilibrium constant or Kc is constant for a reaction. Its value will become constant for a specific reaction, and this equilibrium constant is used to predict the direction of reaction. And the prediction of direction of reaction can be takes place through this ratio, as equilibrium constant is equal to the ratio of the product of the concentration of product to the product of concentration of reactant. So if we know the value of Kc or the ratio of this product over to the product over reactants, then we can determine the direction of reaction, to which direction a reaction can proceed. So here direction of reaction have three possibilities. The first possibility is that when Kc value is larger or greater than the ratio of product to the product of to the concentration of product to the product of concentration of reactant, then if this value is greater than this ratio, then it's mean that Kc value is directly proportional to the product and Kc is inversely proportional to the reactants. So as Kc is directly proportional to the product or concentration of products, and Kc is inversely proportional to the concentration of reactants. So as when the when the value of Kc is larger or greater than the concentration of products, or value of products or concentration of products is greater, and if the value of Kc is smaller, then the concentration of reactants are greater, because here Kc is directly proportional to the product. So greater the value of Kc, greater will be the concentration of products. Here greater the value of Kc means smaller the concentration of reactants, because Kc is inversely proportional to the reactants here. So if Kc value is greater, then it's mean that here the concentration of products are greater and large amount of products are present. If large amount of products are present, then the reactants react together and form products. It means that reaction will proceed in forward direction. More amount of products are required to attain equilibrium here. So greater the amount of greater the value of Kc, then it's mean that the greater the amount of products, and reaction will proceed in the forward direction. Here more products are required to attain equilibrium, and reaction will proceed in the forward direction. So here reaction will proceed in the forward direction. Forward direction. As A react with B, it form product C and D. Here these are products, these are reactants. First of all, we will write equilibrium constant expression, which is equal to the ratio of the product of concentration of product to the product of the concentration of reactants. So here first of all we will write equilibrium constant expression here, and if this Kc value is larger, then it means that there greater amount of products are present. It means C and D are present, and here A and B react with each other and form product C and D. So here a smaller amount of reactants are present, as A and B are reactants, so they are consumed during the reaction. They react with each other and form products, so more products are required to attain equilibrium, so reaction will proceed in forward direction. So when Kc value is larger, then reaction will proceed in forward direction. And other possibility is that when Kc value is smaller than the ratio of product to the reactants, when the Kc value is smaller than this ratio, or this ratio is greater than the Kc value, then it's mean that here Kc value of Kc is smaller. It's mean that Kc is directly proportional to the products, and Kc is inversely proportional to the reactants. So here if Kc value is smaller, then here smaller amount of products are present. Smaller amount of products are present. And here if Kc value is smaller, then it's mean that large amount of reactants are present. So here large amount of reactants are present. Here products are react again to form reactants, so reaction will proceed in reverse direction. So here reaction proceed in reverse direction because more reactants are required to attain equilibrium. So when Kc value is small, then reaction will proceed in the reverse direction. So here reaction will proceed in reverse direction. If Kc value is small, then reaction will proceed in reverse direction. Similarly, if A react with B, it form products C and D. So first of all we will write equilibrium constant expression here, C D to the A and B, which are reactants here. So here smaller amount of Kc means small amount of products are here and large amount of reactants are present here. So products react again to form reactants in reverse direction. So here more reactants are required to attain equilibrium. So reaction will proceed in reverse direction. So if Kc value is small, then reaction will proceed in reverse direction. Similarly, the third possibility is that when Kc value is equal to the ratio of product of concentration of product to the product of concentration of reactants, then here Kc value is equal to this ratio, then here reaction in this when reactants react together to form products, then at equilibrium the concentration of reactants becomes equal to the concentration of products, and here this ratio will becomes equal to Kc, and here the system attain equilibrium and system will be at equilibrium here. So there are three possibilities. The first one is that when the Kc value is greater or this ratio is less than the Kc, then it's mean that greater amount of products are present, because here Kc value is greater, so greater amount of products are present and smaller amount of reactants are present, and reaction will proceed in forward direction. In second possibility, when Kc value is less than this ratio or this ratio is greater than the Kc value, then greater the value of less the value of Kc, it means that less will be the value of concentration of products and large will be the value of reactants. So here reaction will proceed in reverse direction because more reactants are required to attain equilibrium. Here reaction will proceed in the reverse direction. So smaller the value of Kc, reaction will proceed in reverse direction. And if Kc value is equal to this ratio, then reaction will be at equilibrium because here the concentration of reactants will be equal to the concentration of products.